Hello, I'm Ralph Gable of the Electronics for the Inquisitive Experimenter YouTube channel. So far, we've completed the design, we've created a schematic, we've designed a PC board, we've ordered the PC board, and now we have the board right here in front of us. So now what? Well, our next step is to populate the board so that we can get it into our enclosure. And that is what this video is all about. Now, this design uses a lot of surface mount parts. If you're new to working with surface mount parts, I would strongly recommend that you take in my video on soldering and desoldering them before you start working on your own project. I've put a link up in the corner for you. The emphasis of this video is on the process of preparing to build up a PC board and the order of operation for populating the actual board so that you don't get yourself painted into a corner, so to speak. If you have questions or comments, please feel free to add a comment to this video. If you find this video helpful, please click on the like and don't forget to subscribe. Now, before you can populate a board with parts, well, you gotta have parts. The first step is making sure that you have all of the parts that you need. And this begins with creating a bill of materials, or B.O.M, otherwise known as a B.O.M, from the schematic so that you know what you're going to need. Now, I use the B.O.M for three distinct purposes when building my PCB. First, I use it to gather all my parts to prepare for the build. And this is true if I'm going to go to my stash of parts or to a distributor to buy what I lack. I make notes on the B.O.M and mark up the B.O.M as I proceed with this process. Second, I use the B.O.M to know what specific part goes where on the board as I populate the board. Third, I also use it to keep track of what parts I've populated and what parts I have yet to populate. I have one very important piece of advice for you which I cannot be more adamant about. When discussing the creation of a bill of materials while at the airport, be sure to say, I am going to create a bill of materials. Do not say, under any circumstances, I'm going to create a B.O.M. So, this is how we create a bill of materials and get it into usable form in Excel. The first step in creating our bill of materials is to open the completed schematic in DIPTRACE. We want to scrub the schematic to be sure that all of the component values have the same case-sensitive format. Let me give you an example. Suppose you have 5 10K ohm resistors that are all marked with 10K with a capital K, and 2 that are marked with 10K with a lowercase k. These then will be listed as separate valued resistors. Values are case and format sensitive in DIPTRACE. Now we get to export the bill of materials to a file that we can open in Excel. Click on the Objects menu item. Navigate down to the Bill of Materials item on the drop-down menu and click on this. Now let's set this up the way I use it. I set the Group Rows By field to Name and Value. In the columns, the absolute minimum will be the following items: RefDes, or your reference designators, value, quantity. If you've specified manufacturers, then you want the manufacturer field to appear. If you have specified a manufacturer's part number, then you want that field available as well. And then finally, the pattern or footprint. This is so that we know what size a thing is in case we have to order them from somewheres. If you're missing any of these, look over to the right side of the dialog box. With nothing selected in the columns field, click on the Show field. Select the field that you want to add to the B.O.M from the drop-down list of available fields. Click on the Add button. You can change what a particular column is by clicking on the entry in the Column field and then selecting a new value in the Show field. If there are fields in the columns list that you don't want to be there, click on the entry and then the Delete button. Once we have all of the columns specified as we like, click on the Export to File button. We give the B.O.M its file name and where it's going to live in the Save As dialog box. We then click on the Save button. One last step. We have to specify the column divider so the spreadsheet knows where each of the columns belong. I choose a semicolon for my separator. Leave the quotation marks for values checkbox checked. This way, all of the values come into Excel as text as opposed to numbers. Click on the OK button. The file you specified has now been written. Now, our first inclination is just to double-click on it and open it. But there's a much better way to open it in Excel. Open Excel and create a new blank workbook document. Click on the Data menu item. Locate the Get and Transform Data section in the toolbar. Click on the From Text/CSV icon in that section. Now navigate to the CSV B.O.M file that you just created and then click on the Import button. We get to preview the transformed CSV file in a dialog box. Click on the Load button. The now beautified file is loaded into a new spreadsheet in our document. Now we can further format the spreadsheet the way we want it to look. But I want you to notice something as we peruse this B.O.M. Look down here at line 23. I see one reference designator Q121. Now, we expect to see a quantity of 1 in the quantity column because there's only one reference designator. But what do we see here? We see a quantity of 3. But wait, there's only one reference designator. Why do I see a quantity of 3? Well, this is because the 2N3906 transistor is part of a hierarchical block which was placed 3 times. So if you look on the PCB, we see Q121-1, Q121-2, and Q121-3. So yes, there are 3 parts. Thus, while we have only a single reference designator under the reference designators, there is a needed quantity of 3. Well, now that I have my bill of materials for B.O.M, I can begin the process of gathering and organizing my parts. I organize my parts by marking each bag that contains parts with the line number from the bill of materials. Here I'm using small sticky notes to mark my bags. I mark off the parts on the B.O.M as I have them in hand. I file the bags of parts in my project box in B.O.M order. Those things that I do not have, I have to go out to a parts supplier like DigiKey or Mouser to order parts. Now, I have one piece of advice for ordering parts. Do not order just enough parts to build your project. Always order a few extra because, like I have said many times, stuff happens. Among other things, you can count on parts just flicking off into the black hole of the floor or the bench, and you'll wish that you had a few extra when that happens. I've ordered and received all of the missing parts for my bill of materials, and now that I have my parts in hand, it's time to begin the process of populating the board. Well, as we start putting parts on the PCB, we have to be sure that we do not paint ourselves into a corner by putting the parts on the board in the wrong order. I have literally built hundreds of boards over the years, and mostly with surface mount parts. The procedure that I'm going to describe here is what I have found to be the most useful and efficient, preventing me from having to struggle to get some parts on. I always start with the surface mount integrated circuits and transistors. In our case, we have that DC to DC converter, which is sort of integrated circuit-ish, kind of, sort of, but it's tall, and its tallness could get in the way of placing other parts. So this is not included in this initial placement. Now, if you've never worked with surface mount parts before, again, I have a detailed video on how to solder them in place and how to remove them if you have to. And you will find a link to this video in the description for you. As I place these on the board, I mark them off on my bill of materials so I know exactly what I have and have not placed. Once I have all of these parts on the board, I now look at the integrated circuits. I choose the components that reside closest to the chips. These are the ones I populate next. I work myself out from each of the integrated circuits, closest components first, and finally to the ones furthest from the ICs. Once I have all of the surface mount parts on the board, I turn my attention to the larger surface mount parts like the DC to DC converter module on our board. Finally, I mount all of the through-hole parts. Now that we're done putting all of the parts on the board, we have some cleaning to do. Well, all of this soldering leaves flux residue all over the board.
Ew, that's disgusting.
And we don't want to leave that there. As I show in my soldering videos, we want to clean this stuff off of the board. My tool is this hardware store acid brush with its bristles cut real short. I place the board in a vertical orientation like this with several thicknesses of paper towel under it to catch the drips and the drizzles and the drool from the board. My first step is to douse the board with flux remover while using my brush to gently scrub the entire board. Now, it doesn't take a lot of this stuff, so go light. Flux remover like this is available through distributors like DigiKey and Mouser. Once I'm sure that I've adequately scrubbed the board with flux remover, I quickly use some canned air to blow the board free of it. This gets it all out from underneath the parts in the board. My second step is to repeat this process using 99% isopropyl alcohol, dousing the board really well and scrubbing as I go with my little brush. Now you can procure 99% isopropyl alcohol from the local pharmacy. I like my spray bottle, which lends itself very well for this process. Our object is clean, 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 clean. Residue stuff on the board can be highly conductive and just make stuff not work. And I've had several instances where I had not cleaned a board sufficiently and the circuit just totally didn't work, or it worked weird. I closely inspected every solder joint and they were all good. There were no solder bridges, there were no other anomalies to explain the circuit's weird behavior. So I went back and re-cleaned the board and it magically just started working exactly as designed. Now, like before, once we're done with our scrubbing and alcoholing it and everything, we blow off all the residual alcohol off of the board and out from underneath the components using our canned air. Our goal is nice, bright, shiny solder joints all around. We are now ready for final inspection. Make no assumptions about everything being wonderful. You know you did a good job soldering, but you know what? Stuff happens. And this is where we very carefully inspect every solder joint, every pin, everywhere. We're looking for poor solder joints, solder bridges, anything that might not be quite ideal. Use a magnifying glass or manufacturing microscope for this inspection. And I'll use my AMscope microscope that I use to populate the board to do this inspection. Repair, resolder, and otherwise fix anything that might possibly be a problem. But don't forget to clean any new solder joints that you make. With the board being completely and totally ready to go, we're ready to move on to initial testing. Well, now the board is all built. Now we get to see if this works as advertised or as designed. That is the plan for the next video. If you found this video helpful, please click on the like and don't forget to subscribe. Thank you so much for watching. Until next time, Toodle-Oots.